Today the topic of discussion is in doubly circular linked list. In doubly circular linked list, we'll study how to search a node. That is how to search a element in doubly circular linked list. If we say what we have already did in doubly circular linked list, we have seen how to create doubly circular linked list, and in that we have seen the menu program of doubly circular linked list. Then we have seen how to print element of doubly circular linked list. Then we have seen how to insert a node in doubly circular linked list, and we have seen three cases: how to insert a node at beginning, how to insert a node at mid, and how to insert a node at end. Fine. Okay, then we'll see the delete case. And in delete we have seen the delete case, and in delete we have discussed the three cases, that is delete a node from beginning, delete a node from mid, and delete a node from end. So we have seen this 6 plus 2, 8 lectures. Prior to this searching, we have seen these 8 lectures, what we are actually trying to do. Now in the 9th lecture, what we are doing is that we are searching a node. So let's start with the menu first. So we have a menu, and in menu you have a different option. That in function main, you have created a variable of integer type, and then what? While one means what? Condition always true. Condition always true. Why condition always true? Because if you put 1 inside while, if you put 100 inside while, if you put 500, or if you put -2 or -500, anything other than 0 is always true. If something which is always true, it will go inside the while loop, and in after entering you have a different print function. You have different print statements where you have 1 for create, 2 for print, 3 for insert, 4 for delete, 5 for search, 6 for exit. What do you want? Since I want to search, I'll press 5. So the moment I pressed 5, ch will have 5, switch will have 5, and in the moment switch will have 5, it will jump to case 5, and in case 5 we are calling, we are calling which we are calling a what? We are calling a search function. So let's start and see the search coding. So what in search coding we are trying to do is this is simple coding. In search we have created a pointer ptr, and we have initialized with head. Fine. Okay, now what is node 1? As I've already told you, when we have created a doubly circular linked list, structure of doubly circular linked list is something like that, which is having one data part and two address part, one previous address, one next address. So we have created a structure having name node. There are three part: one data, integer type, and two addresses. One is next and one is previous. And then we have created a variable of this structure, which is node 1. And then we have type defined it. So by type defining it means that I have made this node 1 as representative of this structure. That is, node 1 will represent the entire structure. So instead of struct node, I'm using what? Node 1. Fine. Okay. Now what happens? You have a linked list. See, you have a linked list. So you have a linked list which is doubly circular, and you have to search a element. So I've created few variable, one item and one flag. So item, let's see, item. I have not just initialized item, but I have initialized flag with 0. Now I'm asking user, enter the element to search. What do you want to search in linked list? Suppose user want to search 7. So what user will put? User will put 7. So item will have 7. Fine. Then we have, loop. Then we have a loop, for loop. Let's see the for loop. We have ptr. PTR is a pointer. We have initialized with head. That is, this is initialization part. So PTR will have head. What is head? 100. So PTR will come here. This PTR will come here. Okay. I'm sorry, item. I should write this item then. Item is having value 7. PTR is having value 100. Fine. Okay. Fine. Is PTR equal to head? Yes, PTR is equal to head. Is PTR not equal to tail? What is PTR? 100. Is 100 not equal to tail? Yes. What is tail? 500. Yes. This is the second condition. And yes, this is very true. PTR is 100 and it is not equal to tail. Tail is 500. Condition become true. The moment condition became true, I'll move inside the loop and I'll check, is PTR data. What is PTR data? 4 is equal to item. What is item? Item is fixed. Is 4 equal to 7? No. Condition become false. The moment condition become false, I'll not move inside the if block. And what I'll do, I'll increment what? For loop. And in increment, what I'm watching that I'm updating PTR. PTR is having PTR next. What is PTR next? 200. So PTR new value is 200. So PTR node will come here. Fine. Again, I'll move to this second condition. Let me write this very clearly. This is second. This is second. I'll again move to the second condition. I'll check, is PTR not equal to tail? What is PTR? 200. And what is tail? 500. Yes, condition true. What I'll do, I'll again check PTR data. What is PTR data? 5. not equal, is a ptr data equal to 7? Is 5 equal to 7? No, condition become false. I'll not move inside. I'll again update ptr. Ptr will have ptr next. What is ptr next? 300. So ptr will move from this to node 300. Fine. Okay. Now what will happen? I'll again go to the second condition and check. Is ptr not equal to tail? Yes. ptr not equal to tail, because ptr is 300 and tail is 500. Condition again become true. I'll move inside and then I'll check, is ptr data, what is ptr data now? 6 is equal to item. No, 6 is not equal to 7. Condition again false. I'll not move inside if block and again update ptr. What is ptr? ptr will have ptr next. What is ptr next? 400. So ptr will move from this to this node ptr. Fine. Okay. I'll again check, is ptr not equal to tail? What is ptr? 400. And what is tail? Yes, ptr not equal to tail. Condition again become true. Condition is again true. I'll move inside and now I will check ptr data. What is ptr data now? 7. Is 7 equal to 7? Yes, 7 is equal to 7. Condition become true. I'll move inside. I'll move inside and I'll update flag with 1. So flag which was 0 is now 1, and break. Break means I'll come out of the loop. Break will terminate the loop. So I'll come out of the loop and I'll check. Is flag equal to 1? Yes, flag is 1. I've just initialized flag with 1. So what is this OR gate? If one leg of OR is true, I'll not check this. Why? Because if in OR gate one condition is true, what is the use of checking second condition? So the moment one condition becomes true, I'll simply print element found, and which is very correct. 7 is there, which is very correct. Now I'm telling you a condition where you are searching an element which is not in a linked list. Suppose you have already reached to this place and suppose you were searching 9. So what is there in item? 9. So I'm updating item 9 and you have already reached here. So what you did while reaching here, what you did? You checked this. PTR not equal to tail. What is PTR? 400. And what is tail? 500. Yes, condition again become true. You come inside. You came inside and what do you check? Is PTR data. What is PTR data? 7. Is 7 equal to 9? No, condition is become false. Again condition is false. So I'll not move inside. No, and again I'll update PTR. PTR will have PTR next. What is PTR next? 500. So PTR will move from this place to this place. Fine. Okay. Then what will happen? Then what will happen? I'll again what? I'll again check, is PTR not equal to tail? I'll again check this second condition. What is PTR? 500. And what is tail? 500. No, now PTR and tail are equal. So condition become false. The moment condition become false, I'll come out of the loop. I'll come out of the loop because two-way are no, what are the ways of coming out of the loop? Either you have used break statement or if condition terminates. So condition is terminating or condition become false, I come out. I check, is flag equal to 1? No, flag is not 1. Why? Because I have never ever entered this block. So since I have never entered this block anytime, so the value of flag remains 0. So is flag equal to 1? This condition is false. So if this condition is false, now I will check second condition, because for what is OR gate? OR gate says if my one leg is false, check second leg. Tail data. What is tail? This. What is tail data? 8. Is tail data 8 is equal to item? What is item? 9. No. Again condition become false. So false and false is what? False. False and false is false. So condition is false. The entire condition of this loop is false. So I'll come to the else part and what I'll print? Element not found, which is very correct. 9 is not there in doubly circular linked list. So this was all about how to search a node in doubly circular linked list. This is doubly circular linked list. This is doubly circular linked list. Fine. Okay.